Hi guys, my name is Chandan. Registration number is 18BEC0540, slot C1 plus TC1. This is my COA digital assignment 2. My topic is optimized floating point arithmetic unit. Yeah, for this the reference is taken from the paper published by Pratik Singh, Instrumentation and Control Department. So this is also when it comes to the explanation of questions. Yeah, first, how this paper is related to the current COA, Computer Automation and Agriculture syllabus. Digital processors and application specific systems are made of a group of digital arithmetic units. Like in the development of very large scale integration circuit technology, conventional computer arithmetic methods are well known as conventional ones are used. In the past, floating points were usually implemented via coprocessor rather than integrated unit. In this, the IEEE 754 floating point standard provides mainly closely related formats differing in only a few details like single precision and single extended. In the single precision, the format includes 32 bits, contains one sign bit, 8 bits for exceptional and 23 bits for mantissa. In this paper, the operands are 32 bit wide. To choose which operation is to be performed on OP register gives information similarly for rounding modes. Here we use status signals to represent the operation. They are overflow, underflow, inexed, and inexact, exception, and invalid. Here, this is the architecture discussed in the paper, which is drawn by the software encapsulated PostScript. In this diagram, this is the block diagram of it. So we can see different types of gates used in it. So when it comes to the third one, this is the tabulation results on graphs of this selected topic. Here, fixed to floating point conversion is an essential step in floating point arithmetics. To optimize resources and execution time, the certain fixed to floating point conversion is implemented using logic gates. Yes, this table shows relation between fixed point exponent and number of shifts. This is the gate level implementation part from block diagram. This is used by OR gate is mentioned here. And when it goes to the part 2, it includes AND gate and OR gate. This is the gate third. This is the third part implementation. Here we can see AND OR is used in the different based on the use. Here the implementation of floating point unit A is mentioned in the calculation part. Like firstly, we find the difference between the exponent to be calculated. If E1 is less than E2, the difference will be E2 minus E1. And certain example is given for the 5-digit binary floating point numbers. Next is the proposed architecture discussed in the paper using diagramic and vector graphic applications. Here we can see the operation in different steps taken by this system, like shifts and fractions and output signals and signal exception. This is the transition level internal diagrams using electronic schematic square and simulation tools. Here we can see two paths, one is closed path and is open path for the exception handling process. Here in the sixth question we compare the proposed architecture with the existing architecture in the books. This concise technical reference sheet attached below covers many aspects of IEEE floating point arithmetics and implementation details. Like It encloses encodings and parameters. These sections describe binary formats with parameter encodings and conversions between floating point representations and their associated encodings. It includes specific encoding information with examples for half precision, single precision, and double precision and quadratic expression precision. Uh, this results and the presumption exceptions is given invalid divided by 0 and denormal for typical Intel SSC and Intel AVX instructions that implement operation meant to confirm IEEE standards. This includes architecture specific details like NAN priority and denormal exceptions. Control and status words. This section provides a bit level map of the 87 floating point control word and 87 floating point status word and the MXCSR. It includes round control and precision control encodings as well as common abbreviations used throughout the document. These are the list of advantages for the proposed design over the existing design. Some of them are high performance in terms of area and power, latency is reduced, low complexity in designing architecture. Like it is easy to design the architecture in this turn. The proposed floating point unit is able to implement basic computation including addition, subtraction, and multiplication. In this design, division and square root algorithm use the multiplicative method. Multiplicative implementation introduces only small hardware increase due to the share of the multiple unit. Parallel architecture supports high performance application. Energy is efficient as compared to the fixed point unit. Better accuracy is provided by it and provides a very large range of numbers. There are different merits and demerits for the proposed paper. Like the floating point operations in digital systems form an integral part in the design of many digital processors. And in the recent years, many approaches for the floating point operation have been proposed on their merits and demerits compared to it. For floating point operations, the operands are first converted into IEEE 754 format in either single precision or double precision. In this paper, floating point operation unit architectures are reviewed. Few designers work on high speed architectures for reducing the delay of the overall circuit. Further, floating point multiplication is one of the major operations in image and digital signal processing applications. The single precision floating point multiplier acquires the design of efficient 24 to 24 bit integral multiplier. In modern days, computers use conversions for represent non-integral integer numbers. The IEEE 754 standard for floating point arithmetic gives binary representation of floating point numbers of varying precision. Sir, here is the block diagram of the method. The applications of the proposed design is as follows. Uh, the fused floating point add subtract unit is used manually in the application. The main application is in fast Fourier transform and decreased for cosine transform. Butterfly operations such as FFT are benefited with the help of this FPU in term of low power consumption. This is the flowchart of transition level circuit proposed in the design. Uh, there are three stages of arithmetical operations in this flowchart. They are arithmetic core and pre-normalized stage, arithmetic core, and post-normalized stage. In pre-normalized stage, the operands are converted into formats so they can be handled easily and efficient. In arithmetic core, basic arithmetic operations are done. Lastly, in the post-normalized stage, the result is normalized and converted into a format specified by IEEE standard. Yeah, by this we can close this assignment too. this is the reference paper used for it. So once we can take a look of it. These are the references for it. Some of like Dr. D.G. Bailey and N. Sorkin. By this, my assignment, digital assignment expression is complete.